Here's the answer for day 3, problem 1. Graph this inequality. As soon as I see this, it makes me think of a boundary line and shading. This is a is less than symbol, so that's going to be shade under. Because of that little line underneath the arrow, that's a solid boundary line, not a dashed boundary line. So I know those two things going into the problem. Now I want to pay attention to what kind of function this is to decide how to graph the boundary. This is quadratic, so this is going to be a parabola. In this parabola, there's an x squared term and a constant term. When there is no x term, the vertex is located on the y-axis, in this case at -1. The reason that happens is because of the formula for vertex. Remember, it's x vertex equals -b divided by 2 times a. In this expression, a is 1, but with no x term, b is 0. And in case you need it, c is -1. Using the formula -b divided by 2a when b makes 0 gets you an answer x equals 0. When you plug in 0 for x, this turns out to be -1. And that's why the vertex is at -1 on the y-axis. To make the branches, you can make an xy table. Or, depending how experienced you are, you can use patterns. When the value of a is 1, another dot is over 1, up 1, and to the left. And for yet another dot, you could go from the vertex over 2 and up 4. And there'll be a corresponding dot there. Remember, we said it was a solid boundary. So draw in a parabola. And we had already identified that you shade under the parabola. Day 3, problem 2. Identify the restricted values of the function. What numbers are you not allowed to use for x? Because that would create an undefined situation. The variable x is located inside of a square root. And we know that in the set of real numbers, you can't take the square root of a negative. So we can write that x minus 5 has to be greater than or equal to 0. Then solve this expression by adding 5 to both sides. X is greater than or equal to 5. This statement about what x has to be is called the domain. But if we think about what this means, this also tells us the restricted values. If x has to be greater than or equal to 5 to work, then anything less than 5 is restricted. In a question like this, where you asked to think about what numbers work and don't work for x, I will accept a statement about the domain, that is, what numbers work, or I will also accept a statement about restricted values, the numbers that don't work.